Hello friends, welcome. World Health Organization has estimated 12 million deaths, a major challenge across the globe to handle this problem. In today's video, I am going to cover how we can resolve, prevent the diseases to avoid this problem with the help of machine learning. In today's video, I am going to cover logistic regression implementation end to end. I will be covering explaining the data set, the code and everything from the interview perspective. If you don't have time to watch this video, I would say pause it, and whenever you get time, you can watch this video. But don't skip the video. Video will be little bit long, but I am going to cover a lot of things from the knowledge perspective as well as the interview perspective. Before going to start the implementation part, I am going to spend little time to explain you how you can understand the data set. The data set is available on the Kaggle source. You can take it from there. Have information like sex, age information, currently the patient is a smoker or not, how many cigarettes is taking in a day, what is the medical history. So for the cause of the heart attack, all the parameters captured in the data set, which you can check it. Before going to implement it, let me go and load the data first and then tell you. This is my Jupyter notebook. I have written the code just to save the time. So if you look at this code is the basic libraries that is used, NumPy and Panda, and some of the visualization library like Matplotlib and Seaborn that is used for basic libraries. In the second tab, you can see I am loading the data. The data is already kept in my local drive, and this is the path of the data. If I loaded this data, and let us see what exactly in the data by printing some of the row. Here I am printing 5 row. You can look at this data, what are the columns available in the data, and you can see these are the columns and this is the data. Now let's move to check the info of this data, the information about this data. If you execute this code, you can see here some of the information like what are the attributes are integer. If you look at these two are integer, these are the floating point value, right? And then some of other information you can see it in the data set, like these are the entries 4238, 4238 records are available in the data set. Now let's move to describe the data to see some hidden pattern in the data. Once I describe this data, you can see the columns along with the valuable information. For example, count, what is the mean, what is the standard deviation, and then minimum and maximum value, 25% data, 50% data, and 75% data. I'm not going to explain all the attributes, but I'm going to pick some of the attributes which are very important. For example, let us suppose age. If you look at this data, the age is 49.58, something close to 50 years. It means that in the data set, the majority of the people are close to 50 years, which is quite young people are available. If you look at the another column, cigarette per day, here you can see the mean value is 9. It means majority of the people are a smoker and taking close to 9 cigarettes per day. If you look at other information, for example, if you look at other information which is very important, cis BP, if you look at the BP is somewhere 132, it means the majority of the majority of the people are in a condition of pre-hypertension. Because the lower and upper value for the blood pressure is 80 and 120. Here if you look at the data, it's somewhere close to 132. It means they are on the pre-hypertension condition. So these are the information. Once you describe the data, you can easily interpret it with once you describe the data. If you look at 25% to 25%. In 25% data, the age is 42. So this information and maximum age of the data in the data is 70. If you look at what is the highest value of BP, if you look at that is 295. Oh my god. So these are the information that you can derive from the once you describe the data. Now let us move to see if is there any null value. Before going to build the model, we need to first check the data, and then we need to pre-process the data. The first pre-processing is to check the null value in the data. So if you check how to check the null value in the data, we need to simply call is null, and then the sum function will count how many rows the value is null. If you look at in education, 105 records is missing. Cigarette per day, 29 row, the data is missing. BP, 53 record, and the most important, the glucose level, 388 rows, the data is missing. So this information is giving us a clue that data is not neat and clean. Now our job is to handle this null values first before going to apply. How to handle? We need to drop, the best way to drop those rows from the data set before applying the model. So how to drop? We simply use the function drop NA to drop the columns. If you look at by this code, we have already dropped, and now again check the null value. You can see there is no null value, all 0. It means the null data is already been cleaned from the data. The second part is to if you look at there are the column where the data is categorical. To handle this, best way to handle it to create dummies. In pandas, the function get dummies will create the dummy column for the categorical value. For yes, no, these are the categorical values, and it will drop the first row, and it will create a dummies in the data set. In the second, if we'll go back and say now the job is to create the x and y variable before fitting into the model. If we look at the data set, there are two predictors. All is input variable, but there are two predictors that we can predict by logistic regression. The first one, we can predict whether by this data set whether the person is diabetic or not. This could be one predictor. And the second one, what is the chances of heart related problem in coming 10 years. So these two predictor we can take it to predict. Initially I am going to take to predict diabetic. So rest of the column will be our input variable, and diabetic column will be our y, the predictor value. So here I am creating a frame where that is A, where I am keeping all the input variables in one frame, and the predictor will be another. So here A include all the input values except the diabetic. So this one will be my x, this A will be my x, and the y will be my predictor, and that is diabetic, that I am making it, reshaping it to y. Now let us build the model. I am importing logistic regression, splitting the data into train and test by, if you look at the size, 33% data will be my test data, and remaining the data will be my train data. Now here I am initiating the model and fitting the model with x train and y train, and then I am checking the score here. If you check the score, I am getting 99%. So you can put the data, test data, to check it whether the person is diabetic or not, because my predictor is diabetic here. Now let us do the same thing with the heart diseases. So in that case, In that case, diabetic will be my all, including all other attribute, including diabetic and all other attribute, that will be my input variable, and 10-year CHD will be my y variable. So x and y I have mentioned here. Now I am importing the model, splitting the data, and then fitting the model. And let us see the score. The score I am getting 0.84. That is not bad, but not good as well. You can use the other technique and other parameter tuning to improve this score. I hope you have understood the implementation of logistic regression by using the dataset heart diseases. I hope you enjoy the video. We'll meet in the next video soon.